To play the game 21, you deal out 4 cards. All of the jack, kings, and queens have been removed from the deck. So I used a random card shuffler. That's why it says that there's only 40 cards in the deck. So you deal out 4 cards. You must use all 4 cards exactly one time. You can use the operations addition, subtraction, multiplication, division, squaring a number, or square rooting a number to result in the answer of 21. Over time, you'll get used to some patterns that will make this process a lot faster. But for now, you can use a whiteboard or calculator or whatever you need to do to try to get the numbers to 21. I'll show some examples so that way you'll get used to some of the patterns. One pattern I look for are getting the numbers down to 3 and 7, because if I can get to a 3 and a 7, then I can just multiply them and I have 21. So for instance, 3 plus 4 is 7. So I'm doing 3 plus 4 times 9 minus 6 is 3. So now I have 7 times 3, 21. Aces are in the deck as well, and I want you to know that you can actually choose if the ace is a 1 or an 11, whatever works best for you in the situation. I already see another 7 and 3 pattern here. I have my 7 right there, and then I can get this to 3 by doing 8 minus 6, which is 2, and then 6 divided by that 2, which is 3. So I've used the 6 divided by the 8 minus 6 right here. 6 divided by 2 is 3 times the extra card 7, which is 21. I'm also noticing that 8 plus 6 plus 7 is 21, but the problem is I have an extra 6 that I need to get rid of. So I have to use all 4 cards. If you have 2 of the same card and you need to get it down to just one of those cards, you can multiply them. 6 times 6 is 36. And then take the square root of that number, which gets us down to 1/6. So now I can do 8 plus 6 plus 7, which is 21, but I've used all cards. There's another 7 and 3 here as well. 6 divided by 6 is 1. 8 plus, that's 6 divided by 6. 8 plus 1 is 9. Well, you could take the square root of that. A 9 can be a 3 or a 9, because square root of 9 is 3. So you can then do the square root of 9 times 7, or 3 times 7, which is 21. Here's another one I can do a bunch of different ways. A 4, you can think of a 4 as a 2 as well, because the square root of 4 is equal to 2. So the 4 can either be a 4 or a 2. So I could change this to a 2. And so I can do 5 times the square root of 4, which is my 2, which is 10. Plus the other 10 is 20. Plus ace, I'll use that as a 1, is 21. You can use a 5 and 4 pattern as well. So I try to get the numbers down to a 5 and a 4. Here it's not too bad because I can do 11 minus 10, treat the ace as an 11. 11 minus 10 is 1. So these together become a 1. And then I can do 5 times 4 is 20 plus 1. Another thing I can do, always with 5 and 4, whether I have a 1 or not here, if I just can get them to 5 and 4 only, you can square the 5, which is 25, and then subtract 4. So I'm taking this 5 squared, 25, minus the 4 card, which gets me 21, and in this case I'm then going to multiply it by the 1 that I got from 11 minus 10. So I see that 10 times 2 is 20, plus 1 is 21 right away, but I have this extra 4. So I want to try to get rid of that. So one thing I could do is I can do 4 divided by 2. So if I take the 4 divided by 2, that gets me 2. And I can multiply that by the 10. So 10 times 2 is 20, plus treat the ace as a 1. So 20 plus 1 is 21. I also have a 5 and a 4 here. I can do 10 divided by 2 is 5. So it was 10 divided by 2 is 5. Square that is 25. Minus 4 is 21 times the ace as a 1. This game takes practice, but students in the past have got really good at it. At first, it would take us about 10 minutes to get through the deck. By the end of the year, the whole class could get through a deck within 50 seconds, 50 seconds.